Perfect. Thanks everyone for coming. My name is Serban Constantinescu, and this is an unofficial guide to trunks table. For those of you that have not heard of trunks table before, this is a new Android development model that you're going to learn a bit more about in the next few slides. So just before we start, a little bit about myself. I've worked on Android for close to 13 years now. Almost half of that time I worked on Android from at ARM. I've contributed significantly to porting Android to ARM64, ARMv8, so 64-bit. I've also PM'd a technology called ARM Memory Safety. This is basically a hardware technology that helps with catching buffer overflows and use after freeze. And then at Google, I was the PM for a bunch of technologies that you've heard about in some of the previous slides. I led Android virtualization, I led Android runtime and Android native teams. I've also led Android regulation, and in the past few years I've been working a lot on regulation and longevity. This is basically Android's initiative to keep devices around for longer. Last year I left to start source.dev together with David, who's here in the audience, and also Guillaume, who's back there, where we're basically building a operating system for the operating system, kind of. We're trying to make it easier for some of you folks to be able to develop, but also to maintain those code bases for a long time. We're putting all the learnings we've gathered across the years to build this. And we're hiring. I'll tell you more about that towards the end. So just the last thing, please take this as an unofficial guide. I've been deeply involved with a lot of the decisions we'll discuss here, but I'm no longer a Googler. So please take this as the unofficial guide. And as we discussed before, many things are changing quite rapidly. So you might want to check the code base, even if I claim some things here in this deck. So just a quick overview of what's trunks table. So trunks table is basically a new upstream Android development process where all the releases are cut from a single main development branch. And that branch must remain stable at all times. So it must build and pass a set of tests. This basically requires that all new features are developed behind flags, so that on a case-by-case basis, those flags could be enabled or disabled to maintain code base stability. You'll see in a second why this model was very much needed. But basically, Google advertises this as streamlining development and improving quality. So probably the best way to describe why the new model works and why it's so useful is to take a look at the old development model and to try to understand what wasn't working in the old development model. So if you look at it from a timeline perspective, the old development model kind of looked like this. You had an Android version being released. Then soon after that Android version would be released, or actually internally even before the Android version would get publicly released, we would start working on the next Android version. Then you would have a portion of code freeze. This is also known internally at Google as Dr. No. You would need to get approvals, many approvals to get patches merged into the code base. And then the next version would basically get released. So behind the scenes, this model kind of looked like this. Folks like me, PMs, would go off and write PRDs and figure out what we're building and why we're building and what's the minimum viable version of that. And then together with the engineering teams, we would start working on those features. And then almost a week or 2 weeks before code freeze, hell would break loose, literally. Like everything would be merged into the main codes. We would all be dogfooding our devices, and those devices would stop working. And that period over there kind of correlates with the time my wife would get very mad at me because my phone would almost never work. But the important thing here to highlight is that because the timeline was somewhat fixed, that meant that we had to compromise on a few things, and some of those things, some of those features might not have been ready to be released or would have required a longer period of time. So from a quality perspective, if we look at the same thing, it kind of looked like this. We would release an Android version, and in the background we would still be eagerly working on stabilizing that code base. We would hit some sort of stabilization point after releasing the code base, and then again we would do the same thing where the quality would drop when we start merging all these features. Just to put this in perspective, I think the Android engineering organization today is about 4,000 engineers at Google. We would work very closely with some of the ecosystem partners. So think about similar numbers from the lead SoC vendors. And then think about the churn that would go on in the code base. I think Android aosp, it's about 120 million lines of code today. Android aosp, as you folks know, is not actually the full Android. So you can imagine that the full Android is even bigger than that. And I'm sure that some of your internal code bases are very big as well. So imagine the amount of churn that would go on there and how difficult it would be to get this on. So just sort of like a recap, if you think about this model chooses a fixed timeline, kind of fixed set of features, and then kind of doesn't prioritize quality. And this model has worked actually for many years. Early versions of Android didn't have these problems. It probably became really significant in Android 12. If you search Android 12 online, there are many articles, including The Verge, that say, wow, this wasn't the greatest release. And it was primarily because of that reason. So by comparison, this is the new Android development model from a timeline perspective. So instead of having one release, you have 4 releases. Throughout the year, every quarter, you have a new release. This is unlike the all QPR model you're used to. The all QPR model would primarily be bug fixes. This is actually features all the time. Features get released. Obviously, bug fixes and security fixes. And then you have these 2 distinct releases. So you have Q2, which is a major SDK release that comes a lot earlier than old Android would get released. So you get public Android around Q3. Now you get it around Q2 because that basically expedites all the development towards products in Q4, which is the peak of product sales. So that gives folks 1 more quarter to work on that. Q2 has API changes, so new features developers could use. Q2 also has behavior changes, so changes in the API surface that developers would use. And also, not mentioned here, but Q1 or Q2 have sort of like the HAL changes. So if you're a SoC vendor, you probably just have to focus on one of those. That would be your major release, and then obviously you need to iterate with the others, but those would be when the HAL changes happen. And then Q4 is effectively, think of it as a developer preview. It's APIs and features, no behavior changes, but developers would have sort of like a minor version that they could target in their application so that they provide earlier feedback towards the next year, towards Q2. So for this model, you're obviously going to have features that take a lot longer than a quarter to build. Most of the Android features take a lot longer than a quarter to build. And you would have features behind flags. Only the features that are ready to be released would be turned on by the flagging system, and everything else would remain turned off. And you basically have every release would probably have a slightly different set of features enabled, a slightly different set of flags, where probably every feature would inherit from the previous feature and add a few more on top of it. So from a quality perspective, assuming you've got like the right systems in place, this kind of looks like this. So you'd be able to quickly revert features that don't work, turn off flags, and things like that. Actually, if you follow closely the Android code base, some of these systems are already present in the OSP code base. You would see flags turned off automatically by an agent, not an AI agent, but like an agent that actually does something that's useful. And that agent would basically monitor that the code base is stable, or if it's not stable, it would try to bisect and identify the flags that have been turned on and then turn them automatically off. So from if you look at this model obviously chooses features and quality, prioritizes quality, which is very important, and then kind of has a more granular release mechanism, which gives developers more opportunities to release the features that make the Android code base great. So if you put them side by side, the old development model and the new development model kind of looks like this. The old development model was branch-based, even though David corrected me on this. Actually, internally, you don't have that many branches, but you have a lot of code that's flying around. So the old development model, you could still say that's branch-based. Teams work separately, and then towards the code freeze, everything would be merged back in. You have a yearly release cycle. Those QPRs actually are not that meaningful, or didn't used to be that meaningful in the past. And then it's relatively hard to maintain code base quality, and you get only one SDK release per year. By comparison, the new development model is flag-based. There's a quarterly release cadence. And in theory, it's easier to maintain code base quality. And as I said, you could already see the benefits of this in AOSP. And then you get a few more SDK releases per year, which is also important because what the old model was missing was feedback from developers on API usage in the applications and so on. And this model enables that. So if you look at it from a downstream OS fork, and you can think here of a downstream OS fork, sort of like an OEM OS fork, but you could also think about automotive, for example, or other verticals. Those are OS forks as well. The old model had a bunch of problems around sort of like rebasing and testing cycles. Some of the bigger OEMs I had the pleasure to work with across the years. For them, this yearly rebase would be a significant productivity hit. Like basically the whole team would have to rebase a massive code base. It would be difficult to identify issues released upstream. Actually, we've heard this a lot. I won't go into details, but you can imagine it's finding a needle in the haystack. And by comparison, the new development model in theory makes it easier to rebase and test continuously, easier to identify upstream issues, easier to bisect, and that would hopefully reduce the time to update the code base. I think the last thing I'll say on this slide is that this is primarily for Android proper, so Android phones, but you will see some of these trickling down to the other verticals. So if you're doing automotive, wear, or anything else Android related, sooner or later this would be coming your way. So you might be asking yourselves when to use flags. I'll start by saying most big modern code bases use flag-based systems. There's almost nothing out there of the size of Android, and actually even order of magnitude smaller, that doesn't use a flag-based system. Google Play, GMS Core, Facebook, TikTok, all of those code bases use flag-based releases. So you should use a flag wherever your change might lead to code-based instability, and that most likely is for everything. So all major features need to be behind this. Complex bugs, API changes, behavior changes need to be behind flags. The place you would not use flags would probably be comments, small changes, or where the flag already exists. And I think this kind of requires a lot of change in the engineering mindset. It's probably better to start from a place where you add flags everywhere rather than not add flags everywhere. So there are two types of flags that you could use in Android. There's runtime control flags, something that's called aconfig. These are basically used in C, C++, Rust, and Java. You basically declare a flag in a .aconfig file, and then you could check that at runtime if the flag is set or not. And then there are two types of flags. Read-only flags. These flags are basically the flags that would have for the release. Once you set the values as read-only, compilers would actually understand that some portion of code is that code and would eliminate that and optimize the code for you. But you also have read-write flags, and this is what we use during development. And actually, this is how you do a lot of at-scale A/B testing. So you'd have one dog food population with the flag set to on, one dog food population with the flag set to off, and you would see what are the benefits of that change and feature. And then at scale with the right DevOps system behind it, this helps you out. You also have build time control flags, and these are used for low-level firmware changes. The Android virtualization framework uses this, for example, because it has changes in pre-built code and other changes that require build system changes. I won't tell you more about flags, but you can take a look here how to use A-flags. That's a pretty comprehensive guide for that. And then for build flags, I didn't find the right documentation, but if you look inside the build folder and just do a git log -p and take a look for a change that adds a build flag, it's pretty self-explanatory. So there are a few release flavors. And if you look here, I basically start the cuttlefish target, and then I invoke this command, list releases, which would basically give me the releases that are available for that target. aosp current, that's basically mapped to the latest release, which in this case is AP4A. AP3A and AP2A are releases that came before it. Then you have trunk staging, which is basically a development configuration. You could take a look at trunk staging as like an indication of what might come up in the next release. And then something that's not public is this next release that Google has internally, which describes sort of like the dog food population. Also, what I wanted to show you is if you go in the build output, you could take a look at what are the flags enabled for your particular target. And what's really neat about that is that you also have a description for all of those flags. So for folks that work downstream of Android, this is actually quite helpful. Some of those descriptions are not set up until the flag actually gets publicly released. But you could have an idea of like what the next Android might look like. Similarly, if you look at the aconfig flags, if you go and pick a new Android phone, connect it to ADB, and then run this command, that command would tell you what flags you have on that device. If you actually run this command, you'll see that there are many, many pages of flags. There's flags used for everything right now. This is just a short shortening of that. And as you can see, those flags can have different default values. They could be read-only, they could be read-write, and then you also have a namespace. The namespace basically says where you could read that flag from, and so on. I'm not going into other details here, but as I said, some of these flags could be server-controlled. So you could think of a system where you could actually control some of these flags server-side, so that you do those A/B populations and stuff like that. And that's actually what the big companies that do Android at scale do here. So from a life cycle perspective, it kind of looks like this. You add a feature flag. You start developing behind a feature flag. You enable it locally for testing. Then you enable it dog-food or team-wise. And then you enable it in the next release. And then, as I said, automated systems could actually go ahead and disable that. And that could also be downstream automated systems that monitor stability for whatever use case you might have. So you might be thinking by this point, well, that's cool, but when would I get that? There's actually a lot of regulation coming in that says you need to get security updates and OS upgrades. There's regulation coming in for all the verticals. In 20th of June this year in Europe, all smartphone and tablets placed on the market would have to support devices with 5 years of OS and security updates after the point of placement. Point of placement for some devices could actually mean 7 years of updates. And there are some companies that have already made some announcements in that direction. But there's something that explicitly says that features or OS updates need to be released within 6 months of public release. So I'm not a lawyer, but I'll let you interpret that, and you have a FAQ here that talks more about it and gives you a link to the law. So that's it. Thanks. I also have a quick shameless plug. We'll be posting this in aosp-devs, but we're hiring. If you want to work on something that's very exciting, sort of like an operating system for an operating system. We use Rust, we use all sorts of kernel technologies, we use Renelic, and a bunch of other cool things. Come chat to us or send me an email at Serban@source-of-dev. You'll also be working with former Android team members, so that should be super exciting. Thank you.